Okay, in this video we're going to look at reading histograms. Before you watch this video and reading histograms, I'd recommend watching 3 other videos. They are drawn histograms, frequencies from histograms, and also the median from a histogram. Okay, so let's have a look at a typical question. So the first part of the question, I've actually skipped this part. It's got you to draw a histogram for a set of information. So I've just drawn the histogram. I worked out the frequency density for each of the bars, and I drew the histogram. Okay, so let's look at the next part of the question. The next part of the question says, estimate how many nearland boys weigh between 55 and 67 kilograms. Okay, well let's have a look at the table again. So the table's got weights of people, and we're trying to find between 55 and 67. So 55 to 67, so we're really looking from about here, halfway, this one to about 67 in here. Okay, now there's different ways you can do these questions. First part of it, you can just use the table by doing it. So you want to find from 55 to 67. Well, 55, well that's halfway for this group, so that would be from 55 to 60. 55 to 60 would be half of this group, so we would have 13 from this group, because you want to find from 55 to 67, so 55 to 60 would be 13. 60 to 65, well that's all in this category, so we'd have all these 25 people. And the next one then is from 65 to 70, and you want to find 67, between 65 and 67. Well, from 65 to 67, well this group's 5 wide. We want to find 65 to 67, that's 2 across, so that's 2 out of the 5, which is 2/5. So it's just 2/5 of this group. So you can do 2/5 on your calculator. So, or you just don't need your calculator. 2/5 divide by the bottom times by the top. Divide 30 by 5 and you get 6. Times by the 2 is 12, so you get 12 there, and then you add them together. 13 plus 25 is 38, plus 12 is 50. That's one way to do it. Alternatively, you can use your histogram. I'm going to look at that method now in a bit more detail. Okay, so we want to find from, the question said, find from 55 to 67, so I'm going to get rid of that for now, and we want to find from 55 to 67, which is here. Okay, so that's what we're trying to find, from 55 to 67. I'm actually just going to draw up here from 55 and 67 and draw all the way up here. Okay, so what we're trying to do is we're trying to find the frequencies of these three little small bars. We want to find the frequency of this bar, frequency of this bar, and the frequency of the small bar here. Okay, do you remember from earlier? Frequency, look at the video on frequency from histograms. Frequency equals frequency density times collapse width. Okay, so if you times the frequency density by the collapse width, you get the frequency of each bar. Okay, so let's have a look at the first bar here. The first bar here goes from 55 to 60, so it's got a collapse width of 5. The frequency density for it, well, the frequency density, we worked it out in this part of the question, was 2.6. Well, there's 2.6, so it's got a height of 2.6. Well, if you do 5 times 2.6, you'll find out how many people are in this bar. So I'm going to do 5 times 2.6 equals 13. So there's 13 in this bar, which, we worked out the over method, but there's 13 in that bar. Okay, next bar. Well, the collapse width of the next bar is from 60 to 65. Actually, it's the whole of the next bar in it. So 60 to 65. Well, I don't actually need to do this because I know it's going to be 25 anyway. But the collapse width for this bar is 60 to 65 is 5. It goes up to 5, so the height of it's 5. 5 times 5, there's 25 in this bar here. And finally, the bar from 65 to 67, because we only want to find this strip here. So 65 to 67, it's got a collapse width of 2, and it goes up to 6. 2 times 6 is 12, so there's 12 in this bar, and then that's it. You can add up those 3 numbers. You can do 13 plus 20, what number was it, 25 plus 12, and you add those up and you get our answer of 50. And there you go, there's a typical reading from histograms question. Okay, we're now going to look at probably the hardest type of histogram question you can get on the GCSE. And there's a histogram drawn for you, and it's got frequency density, and notice there's no numbers up on the axis for frequency density, and you've got the speed of the cars along the horizontal axis. Now, it says 90 cars are travelling between 50 to 60 miles per hour, so 50 to 60, there's 90 cars in there. It says use the histogram to calculate how many cars were travelling between 70 and 90 miles per hour. Okay, now This type of question is key to remember that the area of the bars are proportional to the frequency. Okay, so what we can do is we can work out how many squares are inside of this bar here, or these between 50 and 60, so we can work out how many squares are between 50 and 60. We know that's for 90 cars, so we work out how many squares one car is worth. And then for 70 to 90, we can work out how many squares are in here. And then because we know how many squares one car is, we can divide the number of squares here by how many squares one car is to tell us how many cars are all together. Okay, so let's do that. So, let's work out the number of squares between 50 and 60. Okay, between 50 and 60, you have got, let's do this little one first of all. There's 1, 2, 3, 4, 5 across, and 1, 2, 3, 4 up. So this bar here has got 20 little squares inside of it. This one is 1, 2, 3, 4, 5 across, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 up. So it's 5 times 26. 5 times 26 equals 130. So this is 130 squares. So altogether, between 50 and 60 miles per hour, there's 150 squares. 150 squares, and that is for 90 cars. So 90 cars equals 150 squares. So let's work out how many squares one car is. Okay, so if we divide this by 90, okay, if we divide 150 by 90, we'll find out how many squares one car is. So do 150 squares for the 90 cars divided by 90 tells us that each car is 1 and 2/3, 1.6 recurring, 1 and 2/3, 1.6 recurring squares equals one car. So I know each 1.6 recurring, each 1 and 2/3 square is a car. Okay, let's work out then how many squares are in the part that they want us to work out between 70 and 90. So we're going to have to do our 3 bars, see how many squares are in each. So there's 1, 2, there's 10 across for this one, and it goes up 5, 10, 15, 20, 22 and a half. Let's just check that. 1, 2, 3, 4, 5, 10, 15, 20, 22 and a half. Okay, so it's 10 across times 22.5 is going to be 225. Okay, the next bar, it's 5 across, this one, and it's 5, 10, 15, 20, and 25, no, 26. I'm going to have to count this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 up times 5 is the same as this one, 130. And finally, the last bar, it's 5 across, and it is 5, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up. 5 times 11, 55 squares. So we've worked out altogether this section between 70 and 90, which it once has got 225. We're going to need to add these up. 225 plus 130 plus 55 is 410 squares. So that's 410 squares. Now, it's 410 squares, and we know that each car is 1 and 2/3, or 1.6 recurring squares. So if we divide the 410 by the 1.6 recurring squares, we'll find out how many cars are in this section. So, 410 squares divided by 1.6 recurring equals 246 cars. So in this section here, there are 246 cars. And that's it done. The typical A-star GCSE question. Well done. And finally, here you can see that that type of question is quite popular. Another type of one, we'll not do it, but we'll just read over it. We've got a histogram drawn for us. It's got no numbers on the frequency axis, or frequency density axis. And then it says 42 leaves are measured 25 millimeters or less. It's told us how many are from 25 and less, and it says how many leaves measure 60 or more. So what you would need to do is work out how many little squares in each of the sections, and then work out how many squares one leaf is worth, and then divide the number of squares in this section by how many squares each leaf is worth, and that'll tell you how many leaves there are. Simple as that.